is Alex Kipman.
Alex and I have a belief that you can build technology that allows people to interact with their digital world in the exact same way that they interact with the real world.
The development edition of Microsoft HoloLens is ready.
Let's see what's in the box.
There's, of course, Microsoft's HoloLens, the world's first fully untethered holographic computer running Windows 10.
Which comes with things you'll need, like a charger, carrying case, and the clicker.
It offers another way to do things like select and scroll.
Visit the App Store to discover the first wave of HoloLens experiences. Apps, games, and tools for creativity, productivity, and communication. These are our gift to you, the developers.
We've done a ton of work from the OS up. The best, most amazing thing is yet to come.
Welcome to the team.
Let's together transform the world with holograms.
Mixed reality is an exciting new medium for developers and designers to explore. But we're just beginning this journey, and we can't wait to see the kinds of applications and experiences that you'll create. In getting started as a designer or developer with a new technology, we all ask the same question, which is, what kinds of things should I make? What kinds of things are really going to resonate on this HoloLens device? What I'd like to do today is show you what we've learned so far to help get you started on your journey. My name is Joshua Walton, and I'm a principal design manager on the Microsoft HoloLens team. And today, I'm going to talk about 3 different aspects of the project. The first, I'm going to talk about the hardware, and I'm going to show some specific example videos that dive into the details of how to use the hardware. Secondly, I'm going to move on to speak about techniques you can use to create mixed reality experiences. And finally, the heart of the conversation, I'm going to talk about areas of interest that we see for creating compelling applications and experiences. So let's get started. The first question we get asked is, what is mixed reality? So mixed reality is about blending 3D holographic content into your world. I mean, both the digital and the physical are important to me, and I want to find new ways to live seamlessly between those worlds. Now, along with mixed reality, you often say, well, how does this compare or contrast to augmented reality or virtual reality? And you can think of this as a spectrum. And on one end of the spectrum, you have the real world and all of the experiences we have associated by living in the real world. And on the other end of the spectrum, you have completely virtual worlds with information and data that is invisible around us. Now, augmented reality traditionally composites this virtual information and the real information together, but typically through something like a tablet or a phone. And in mixed reality, what we're doing is allowing the people who create experiences and applications to think of this as a spectrum in which you as a developer can move your user between the real world and virtual data items, and back and forth. So my journey started over 3 years ago. And all of my friends back on the HoloLens team, we all wanted to unlock some new ways to create, communicate, work, and play. And so we had a bunch of experiences in mind. But in order to achieve those experiences, we knew we'd have to develop some specific techniques in order to explore them, and to do that, we needed hardware. And that ended in the dev kit that was released this week. And today, as people receive their dev kits, is on the front of the device, you'll see that there's these 4 environmental understanding cameras. And these aren't cameras in the way you and I typically think of a camera. They're really for mapping and understanding the environment. And so as you put on the device and turn it on, it'll begin to map using these cameras. And that map is something which can be used by developers to customize their experience to each environment in which it happens. So I'd like to show a short film that explains a bit about spatial mapping in more detail.
How do you get holograms to run and jump around your living room? Spatial mapping is all of the information that HoloLens has about the real world for use in the holographic world. You can access spatial mapping data through standard Universal Windows Platform APIs or with Unity. You use spatial mapping in your app for 5 main purposes: to help your holograms navigate around a room, to have your holograms occlude a real object or be occluded by a real object, to interact with something, like bouncing off the floor, to place a hologram onto a real object, or to show the user a visualization of the room they are in. Spatial mapping data can be stored between sessions, so it's there the next time you start up HoloLens in the same room. Spatial mapping is key to the HoloLens experience. It lets HoloLens see your real world and enhance and blend it with your virtual world.
So now, as we continue to look around the device, we'll see immediately that it has see-through optics. And these are critical to a mixed reality experience where we're trying to blend the physical world and the virtual world. So using the waveguide technology, we're able to place objects made of light and sound right in your environment. And I'd like to share a short video that explains the basics of the power of holograms.
Microsoft HoloLens brings holograms into your real world. Using transparent lenses, spatial sound, and an understanding of your environment, holograms look and sound like they're actually part of the world around you. That is mixed reality. With Microsoft HoloLens, holograms are viewed through the holographic frame centered in the middle of your view. This preserves your peripheral vision, so you can move freely and connect and collaborate with people around you. Holograms in mixed reality don't block out what you can see and hear. This enables you to engage with digital content and tools alongside the objects in your real world. Holograms can be world-locked in a physical location, so you can walk around them, or they can travel with you. You can even hear them in 3D with spatial sound. Microsoft HoloLens is the world's first fully untethered, self-contained holographic computer. With the mixed reality experience of HoloLens, you can stay in the real world and interact with real people as you simultaneously explore 3D in 3D.
Now, if you were to open up the device, you would see that we had to create some custom silicon to achieve these goals. We call this the holographic processing unit. And part of the goal is to fuse all of the sensor data that's coming in and provide it in an easy-to-understand way for developers. Now, all of these fusions come to you as spatial sound, gaze tracking, gesture input, and voice support. And we do this work on the HPU in order to save the room on the device for your applications and experiences to use the resources of the device. So I'd like to explain just one of these. In this case, I'm going to choose gaze tracking and explain that one in a bit more detail.
Gaze input on the HoloLens indicates where a user's attention is focused. A cursor is used to indicate the gaze direction. As the user's head moves, the cursor follows their point of attention, while remaining centered in their field of view. To determine the point of attention, use a raycast, and then place a cursor on the object that the raycast intersects. The cursor can provide additional depth and dimension information by conforming or hugging the surface that it intersects. Cursors are usually non-directional. They only indicate where the user is currently looking. A ring or donut shape works best for this. However, sometimes you may want to indicate to the user where they should be looking, so an arrow can be added to the cursor to lead them to the action. If there are temporarily no actions or selections for the user to make, then you may want to temporarily hide the cursor so that it does not obscure what they are seeing. Much like a person uses a mouse to move a cursor, they can now use their gaze to target items in a mixed reality world.
And the last part of the device we'll examine are the speakers that create spatial sound. So when we were thinking about how best to use sound in mixed reality, we realized we definitely wanted people to be able to hear the sound in their environment and to mix that with the sound coming from the device. And we wanted to do this in a very special way. So we used a specific model that characterizes how the human ear is formed and receives sound. And we allowed developers to place sounds in the environment at specific locations. This really has to be tried to be believed. I'd like to show a short video that will provide some insight into how you can use spatial sound in your application and experiences.
Developers can use spatial sound to make the mixed reality experience of HoloLens even more immersive. While holograms can only appear visually in front of the user, sounds can come from all directions, creating a 360-degree world of holograms. Use Unity to attach sounds to an object, and then spatial sound will make it seem like those sounds are coming directly from that object. The sounds will be adjusted for the direction and distance the hologram is from the user. Spatial sound can also be effective in getting the user's attention. A sound can indicate the direction to turn to, or let the user know that there are more holograms around them in the world. Spatial sound greatly enhances the HoloLens sensory experience by making your imaginary worlds more complete.
So now that we have a good sense of the hardware and what the hardware is capable of, I'd like to move into a set of techniques that we've identified for developing these mixed reality experiences and applications. At the TED conference this year, Alex Kipman gave people a bold vision of where this technology is and where it's going, a place where you can blend the physical and digital in amazing and meaningful ways. Now, especially for people who are new to mixed reality, we want to make sure we're good hosts and make sure they get time to explore our experiences at their own pace. How many people have had a chance to try a HoloLens? Great. So I have a question for you. The first time you saw a world-locked hologram, you probably had your friend or host talking to you. Did anyone hear anything they were saying? No, right? I still have this today. I need to adjust into all of the kind of sensory input that I'm getting and really make sure that my experience can be comfortable and enjoyable. And it's our role as developers and designers to make sure that people can explore at their own pace and we're sensitive to their senses. The next technique is world-locked presence. And here we have to think about, what does it mean to be present as an object? Well, it shouldn't move. It should feel grounded. It should use light and shadow in an effective way. In fact, we should let the user treat the digital object just as they would a physical object. And I have a great story about this one. So in an experience similar to this, the creator made a hologram on a square virtual table. And they noticed that when people were interacting with different sides of the hologram, they would take the time to go around the edge of this corner of a virtual table because they didn't want to accidentally bump into it. And to us, that was a huge insight, so we took a cue from industrial design and rounded the virtual table. And sure enough, people felt more comfortable moving around that table. This is something we're so used to that we have to rely on our use and sense of the real world to create world-locked presence. Now, as well as being relatable as an object, something really unique in mixed reality is the ability to use true scale. So we can quickly get the best of both worlds in terms of seeing our holograms at exactly the scale that they would be in the real world, and also being able to quickly zoom in or out, or show an exploded view or a magnified view. And true scale, my friend actually mentioned this idea to me that we haven't tried, I'm very curious about. He mentioned this quote from Michelangelo that some of you may be familiar with, where he says, "Every block of stone has a statue inside it, and it's the task of the sculptor to discover that sculpture inside." And we thought, what if we could place a hologram inside a solid block of foam or clay and begin to carve away with tools until we revealed that shape? We haven't tried it yet, but I'm excited to go back and start and see what that might mean in terms of a different way to think about how to use true scale and mix the physical and virtual. Persistence. This is about placing objects right where you want them and returning to them with confidence to jump right back into context. So how many people have ever played peekaboo with a little kid? So in infants, before they have object permanence, when that peekaboo starts, the child thinks they're gone. And when you reveal, they think, ah, you're there, you're back again. And this sense of object permanence develops in our infancy. And this actually has a lot of very practical uses. So for myself, I use the device at home and at work. And when I take it home, I might be working late night on a presentation, and I lay out browser pages, photos, holograms, and I work through the night. When I come into the work next day, I continue my work there, and when I go home that evening, everything is right where I'd left it. So I can jump right back into the context I was working using persistent holograms. Spatial memory. So how many people have heard of super memorizers? They're these groups that you can quickly give someone a 50-digit random number and they can memorize it. And if you look at brain scans from these individuals, it turns out that the area of the brain that's being activated is the one responsible for spatial awareness. And 90% of these people use the same technique. And it's a very old technique called the memory palace. It dates back to Aristotle. And in the memory palace, you lay out information in your mind in a space. And when you want to recall that information, you walk through that space again. And this had us thinking, what if I wanted to learn new words every day? I wanted to expand my vocabulary. What if I could rely on spatial memory and put my new vocabulary words throughout my home? And as I go about my daily tasks, I'm using my spatial memory and the power of my brain to increase my memorization skills. The next technique is audio saliency. And this is really about creating a believable audio world and taking advantage of the fact that people can hear all around them. So though my vision is really dedicated to the front of me, audio can be a great clue to help me turn and understand something that's behind me. And I have a funny inside story from when we developed this. We had a demo of this technology when we first got it working. And there's 5 or 6 of us in a room trying the demo. And someone came late to the demo, and they didn't know what it was. And the key to this demo is that someone had placed a spatial sound at the door, and it was a knock at the door. And we were all discussing the technology and already engaged in the meeting. The person came in late, tried the demo, and they kept looking at us, bewildered. And we'd forgotten what was happening, and we were already busy discussing. And finally, he got up, and he's like, OK, I'll answer the door. And we realized that the power that audio has to provide a rich environment. The next technique that we developed was called tag-along. And this is about being a hybrid between a physical and a digital object. And it takes the best from both. What if you could have an object that moves with you and reacts with the environment seamlessly to create just the right place for predictable use for the user? And one of the ways I wanted to try this, I live in Seattle, and I really want to know how to make perfect coffee. So I loaded a bunch of video tutorials, and I had them follow me around the kitchen using tag-along, where I got the ingredients I needed to make the perfect brew of coffee. And I could do all of this hands-free using voice and tag along, I could complete this tutorial to brew the perfect cup. Waypoints. A waypoint's a reference point in physical space, and it's used for the purposes of navigation. You might think of these as a landmark. And here we really took a cue from architects and interior designers and looked at how they design airports and convention centers. How many people flew into the conference? Yes, and I bet you went to look at that arrival or departure board. And part of this is that we want to create safe places for the user to return to, and they know that they can continue on their way after checking into this waypoint. So in mixed reality, we often create a waypoint where the user knows that they can return to if they need to navigate or change something about their experience or their settings. The next technique are magic windows. These have had many names, but lovingly we refer to them as magic windows. It's a great technique for expanding the scale of the space. And there is a part in one of our apps, and I'm not going to tell you which one because I don't want to create a spoiler, where the floor is going to drop out from underneath you. And people are blown away. It's not a time to be scared of heights. But we realized that being able to play with the space had practical implications as well. For people who are working on mixed reality in a confined area, we can give them a greater sense of space and depth in which to create that experience, but also make it believable as something in their real world. First-person capture is the last technique that I'm going to talk about today. And this is about seeing through someone else's eyes. And I think of this as the ultimate phone-a-friend experience. So whenever I'm trying to learn something a little bit out of my comfort zone, I love to either get a coach or a friend to help walk me through it. And it's something like plumbing or wiring a home that isn't something I'm really used to doing. I can phone a friend and have them see through my eyes and help me understand and walk me through something that might be normally uncomfortable for me. First-person capture is a great technique to get right into what someone is seeing and understand through their perspective. So now that we've talked a bit about the hardware, and I just showed you 10 techniques that we use for creating mixed reality experiences, I'd like to get to the heart of what I wanted to talk about today, which are the kinds of experiences that we believe will create or that are areas of interest to create compelling mixed reality experiences. So there's 6 of these. And I'll start with the first, which is using and viewing 3D content in 3D space. There's a rich world of 3D data out there already. So if you think about science and medicine in terms of medical imaging, or if you think about engineering and architecture, or entertainment and gaming, or even new possibilities within data visualization, a lot of this 3D data is already out there. But right now, it's being viewed through often 2D screens. And we've created interfaces to help people navigate 3D objects in 2D. But by placing 3D in 3D, we might be able to help people more quickly understand, diagnose, or make decisions about their data. As you may be aware, we have a pilot program, and we've partnered with different companies to help explore some of these areas of interest. I'd like to screen a short video that talks about a pilot we completed with Autodesk.
The single biggest challenge for designers and engineers is really just being on the same page, which is really key to making better decisions and better products overall. It's really just communication.
Autodesk has a great mission where we try to help imagine, design, and create a better world.
Tools like HoloLens, together with Fusion 360, it's a single environment where you can explore your idea and share it out.
Because of the tools that designers and engineers have, they have to do this silo approach. What the HoloLens is bringing is the ability for those two worlds to coexist.
It transforms the way people interact with each other, which would radically change the whole design environment that they have today.
HoloLens is bringing this 3D content into the real world. That's the real power of HoloLens.
Found this new package called Fusion 360. That actually is what kicked off the relationship with Autodesk. Modbot is a set of robotic building blocks. It's kind of like Lego for building industrial scale robots. Something like HoloLens will let you actually see the physical size for context, and you won't go making stupid engineering decisions. We can interact in real time in a shared workspace, and that means that we should be able to come to one final solution in one meeting. Fusion 360 is a 3D environment that is very reactive. Having that 3D view into that environment is going to be incredibly helpful.
We're going from design to collaboration to radical collaboration. Because with HoloLens, you have a mechanical engineer next to an industrial designer, and you're all looking at this together.
It could actually mean less physical prototypes. 3D printing is all the rage at the moment, but it would be even better as a model that you can tweak in real time. This is even better. This is the next step.
It's just amazing to see right in front of you the actual 3D model. I could see all the different pieces, and it's completely changing the way people actually approach design.
It's kind of like a portal into a sci-fi world. You can see things that previously you've only seen in movies.
This is going to be a big technology movement going forward. It connects the dots between what's going on in your brain and what you're seeing for real. It's going to change everything.
So one of the things I love in that pilot program is their use of desktop computing with the HoloLens. And they use those things in conjunction to create 3D in 3D. Now, the next area of interest that we see is around telling interactive stories using space. So this unlocks some of the techniques we talked about: persistence, world locking, spatial sound, spatial mapping. But it also lets people take journeys with holographic storytellers as they sit in the chair next to them and talk them through specific ideas or challenges. And we developed a game experience that explores interactive storytelling using space called Fragments.
So I'm in my living room. I took the HoloLens home for the weekend. I'm sitting there, and I look over to my right, and I see the director, Kirkland. And she's sitting there on the couch, telling me to solve the mystery. And I'm just like, okay, this is awesome. And I can't even begin to imagine what we could do with storytelling and with games with that new power of having people in your space, in your home. Fragments is this high-tech crime drama, one of the initial applications that we're releasing with the development edition of HoloLens, where you become the main character and solve mysteries that are actually brought to life by your world.
Investigating the death of Jacob Baker.
One of the key things on HoloLens is the world awareness. As we scan the room, we exactly know where the walls are, where the ground is, where the tables are.
Whenever we know all the information about your room, it starts looking for different points where a character could put his hand and lean against.
When you're playing Fragments now, we're able to put things like, a thumbprint on a matchbook that we hide behind your coffee table, so you actually have to physically get up, you find that pivotal clue and solve the mystery. One of the awesome things about HoloLens is, at its core, it's a Windows 10 computer. It lets you make a Windows 10 application and lets you develop these awesome applications that are ranging everything from as small as Calculator to as big as Halo 5. Working with the Sobo Studio on HoloLens has been an awesome experience. We got a chance to actually work with a developer and explore what it meant to be somebody outside of Microsoft making the world's first holographic experiences.
We have our own proprietary engine, like many game studios have, and we didn't have any problem porting that to HoloLens.
It's a very interesting aspect of creating games on HoloLens is that it's so fresh, it's so new. You basically need everyone to focus on this new paradigm.
I really hope that Fragments shows developers that there's a great opportunity to tell amazing stories with the player at the heart of the experience for HoloLens.
Director, we're receiving a call from the Pentagon. Maybe trying to smooth things over?
But I honestly think we've just begun to scratch the surface, and that other game makers are going to take HoloLens and be able to really surprise people.
So one thing I should mention in the development of these areas of interest is that we spoke with first-party studios, such as Asobo, with our pilot partners, and also some of you may be familiar that we partnered with Microsoft Research to create an RFP for HoloLens in order to understand what the academic community was interested in with mixed reality. And we relied on all of this and our own experience to arrive at what we believe these areas of interest are. So the third area of interest is we believe you can create interfaces for objects and environments using HoloLens. And this uses the techniques of TrueScale, world-locking, spatial sound. And if we think about the way the Internet of Things objects evolved, initially, we designed these objects, we connected them to the Internet, and we put the interfaces right on the object. But that quickly faded away because the cost of embedding that interface right into the object. So then you saw these interfaces move to the mobile device. And often now, if you were to interact with a Bluetooth speaker, for instance, you might do that through the use of a mobile device. But what if you could associate that interface or that content directly onto the object or environment itself? We think this is a really exciting opportunity, and we've been working on a robot, which we've shown at a past conference, and it's been continuing to evolve. And I'd like to show a short video of that robot in action.
Alex.
Hi, Miko.
I'd like you to meet B15. This year, millions of people will use maker kits like this one to enter robot competitions and learn about electronics. Many of them will use Raspberry Pi 2, which now supports Windows 10 IoT Core. We were inspired to see what we could do with the same hardware and HoloLens. So let me show you. B15, wake up. Up. Say hello to the real B15. Because every Windows 10 device has APIs for human and environment understanding, we were able to overlay a holographic robot on top of a physical one. And one thing we noticed while working is you need your data to be easily accessible. But adding displays to this frame increases your cost, and there's no way to see all that information at once. So let me show you how we check on our data. B15 control panel. This spatial UI system is a universal Windows app. I'm pulling the data from B15, making it as big as I need it to be, and placing it where it's relevant in my world.
And I love it that Miko didn't have to actually go back to her desk to do it. This is a great example of how Windows 10 makes your digital life more powerful by connecting it with your real life.
That's right. You can waste a lot of time tweaking variables on another device before you test. But if all I need to do is something simple like change LED color, I can use a control scheme like this. So that's how we envision controls and displays evolving with holograms.
Now, so many industrial robots need to find paths safely through their workspaces. Let's take a look at how Miko can help B15 navigate and how holograms can help.
So B15 sensors aren't great at detecting obstacles, but the cool thing is they don't have to be. My HoloLens can communicate that information. B15 pathfinding mode.
Now with Windows Holographic, we can scan an environment. We can queue up movement tasks and visualize the robot's path.
So all I have to do is air tap the ground. My HoloLens interprets the 3D points and tells B15 when to turn and when to move forward.
Now this is a great example of how portable our Windows experiences can be. B15 didn't have to know its environment. The room understanding comes from Windows Holographic. But what happens when the environment actually changes?
That's no problem. Because I'm wearing HoloLens, I'm always aware of B15. I can see it updated its route to go around you. And this is critical if you're working with bigger robots, like those in automotive manufacturing. you need to always be aware of a robot's intentions. HoloLens helps developers understand robots better at any scale or in any scenario.
This is just amazing. Thank you so much, Miko. And nice to meet you, B15.
B15, say goodbye. See you later, Al.
So if you see the base of this robot, it's based on a Raspberry Pi. And I've been trying to learn how to build one of these myself ever since I saw this demo, because I really want one. So if anybody has any great Raspberry Pi experience, come help me after the talk. The fourth area of interest that we see for compelling mixed reality applications is making the invisible data of the world visible. So imagine our boss has sent us into the warehouse to find that one piece of inventory hidden somewhere in there. Now, how traditionally might we find that piece of inventory? We might have printed a piece of material to go to a specific location, or in a more advanced warehouse, we might use a wrist-mounted computer. But what if we could visualize that invisible data of where that is located right in the context of the warehouse itself? Or think about the invisible data in science and wave technology. For instance, sound waves, or RFID, or Wi-Fi, and this new ability to visualize that in a holographic way. And last but not least, there's some information in invisible data that's just very hard to get to. And it's either expensive or difficult. And as part of this exploration, we have a partnership with Case Western Reserve University. And I'd like to show how we're making the invisible data of the world visible.
We've been teaching human anatomy the same way for 100 years. Students get a cadaver, then they look at medical illustrations, and it's completely two-dimensional, and the human body isn't.
Microsoft HoloLens is a holographic computer that you wear. It enables you to bring your digital world into your real world.
At Case Western Reserve University, we are focused on solving problems and creating new knowledge.
My job is to teach, and I really think this could impact almost everything that we teach people. With HoloLens, you can see the muscles on top of the skeleton all at the same time. You can bring them in and out and exactly understand where things sit.
You can take any anatomical part and show any of it. You can move it around, you can make it kind of translucent so you can see through the outside, and that really helped me understand how cardiac anatomy worked. I actually had a moment where I found the aortic valve, and it was the first time that I'd actually seen the aortic valve in relation to all the other anatomical structures. It was a way of seeing it that you couldn't do with an actual heart.
I think this will improve students' confidence in learning anatomy dramatically.
By creating simulations with the HoloLens that lets them have an experience where they can fail, that would be the best way to learn, because we don't allow people to fail too much in real-life medicine.
With HoloLens, you could imagine having a class standing around a model, almost like a tour group in a museum, where they're all interacting completely naturally. I spend a huge amount of time to make sure they become the best professionals, because it's all of our jobs to make the world a better place.
Working with Case Western Reserve University to create this paradigm shift so that we can leap together with students into the future of education. We believe that HoloLens is going to enable us to do that.
We talked about being able to use it to teach art history. We have an anthropology department, too, that I think will enjoy this technology.
Anytime you change the way that you see things, it changes the way that you understand them. As soon as you can change somebody's understanding, then they can change the way they see the world.
So the fifth area of interest is about extending and augmenting human sensing. And often when people first see HoloLens, they say, oh great, I'm going to be like Iron Man. And I think, okay, well, let's start figuring out how to build that. And part of that is about extending and augmenting the human sensing. So what if we could give people superpowers? What if we could give them the ability to move things with the power of their voice? I could say, move that object to there? Or what if I could work with other kinds of sensors, such as thermal imaging, in order to lay that heat data right over the engine that I'm looking at? And this had us thinking about some of the material, even from this conference, concerning Microsoft's work in cognitive services. And we've been particularly inspired by a project our colleagues at Microsoft in the UK have been working on. And we see huge potential in this area for HoloLens and creating compelling mixed reality experiences.
The aim of Cities Unlocked is to open up spaces and places so that people, everybody, can enjoy them more freely, enjoy them with a greater level of engagement. Phase one was really interesting. Could we enable a person with sight loss to get out and about in a way that enabled them to be more independent? That gave them a greater sense of mobility and empowerment. And the work that we did last year was essentially focused first and foremost on that very, very human experience. One of the core components of the experience still is your ability to get from point A to point B. But I think what we've been able to do in phase two is to really take that to a completely new level. And I think we describe the concept here as your ability to be able to just orientate yourself at any place you want to, whether you're indoors or whether you're outdoors. You're no longer confined to the routes that you've had to learn off by heart. This technology, this notion of a 3D soundscape that basically describes the world around you in audio. It's like audio signs.
Bike rack, about 5 meters.
Through that, you're able to build out a really rich picture of where you are and what's around you, and follow your own nose if something interests you. By virtue of having access to this information, it piques your curiosity, and you begin to wonder, well, what's down there?
When you're using the device, it does paint a picture of the town. It told me all the different shops on either side of the road, but it also told me the names of the streets and also the sort of compass direction. I just think it gives you sort of greater freedom, really, and gives you more independence.
So this is not a HoloLens project, but it's inspired us to think about how they're extending and augmenting human sensing. And I'm sure it's giving you ideas for how you might do that as well. The last area of interest that we see, we call collaborate with perspective. And this is about using the first-person capture and the spatial sound to help people train, to help diagnose problems, the phone a friend experience that I discussed earlier. But also we're seeing, because you can capture mixed reality video from the first person, it gives you a great ability to record your own stories. And something that's traditionally been quite difficult is doing your own visual effects. So what has happened in the past is you'll create your video, and then you'll go into a post-processing phase where you add your visual effects. But what if you could do that seamlessly and record that all in one step? And we have a great project to help you do that, and it's called ActionGrams.
I'm a huge fan of the dinosaur hologram. There are very few situations that aren't improved by a holographic goat.
I think my favorite ActionGram is still our zombie named Ned. He's a great actor.
ActionGram is part of the first wave of launch applications for HoloLens.
The main point of ActionGram is to allow a user to tell a story by putting holograms in their world and then recording them and then share that.
So we give you a huge collection of holographic characters and props and tools, and you can use that to put holograms into the story that you want to tell.
My most popular video on YouTube, one of my friends spent hours adding effects. In the future, with holograms, I could maybe do those things in an afternoon. If you don't know how to use VFX or you don't have actor friends, you can't make the type of content that ActionGram is going to allow you to be able to make.
Our app is focused on humorous content, things that you might want to share online. But there's so many other forms of storytelling, educational storytelling, or instructional storytelling. And I think that's really exciting for developers.
No question in my mind that a small garage development team could easily make a HoloLens application. It's really no different than developing for any other mobile platform. The differences are in how you solve your problems rather than on the technical side.
We're on the cutting edge of this becoming the way people consume media and create media. I'm just so excited to watch that progress.
So I've covered a lot of material today. I started with the hardware and understanding from the unboxing what you'll see in the hardware. And next I moved on to 10 techniques that we see for creating mixed reality experiences. And finally, I've shown you the 6 areas of interest that we think are exciting for application developers. And I bet you all have ideas for what you'd like to make now. And here's how you can get involved. The first step is you can join our community and provide feedback. We thrive on your feedback. The second thing is that you can learn to dev for HoloLens by going to this URL and using all of the tools that we provide there. And lastly, you can order your dev kit at hololens.com. Thank you, and see you in mixed reality.